Hello everyone, I am Trupti ND, Faculty of Walton Institute of Technology, Solapur. Here I am presenting recursion concept in C. Before starting with the recursion concept, we will go through the iterative process. Here, to explain the iterative process, factorial example is used. N factorial. If n's value is equal to 0, n factorial results in 1. If n value is greater than 0, n factorial is represented as n into n minus 1 into n minus 2 till 1. Here example is given 4 factorial. 4 is multiplied with n minus 1, that is 3, multiplied by 2 multiplied by 1. So this repeatedly multiplied till the value becomes 1 and the result will be stored, that is 24. 3's factorial is 3 into 2 into 1, 6. 2's factorial 2 into 1, 1's factorial is 1, and finally 0's factorial is 1. The above process calls for the explicit repetition of some process until a certain condition is met. This process is called as iterative process. So this here in n's factorial repeatedly multiplication is done till the value becomes 1. So the condition here is the value of n which is multiplied becomes n. So this process is called as iterative process. What is recursive process? Redefine the above factorial example. The same factorial example if you are representing in with the recursive method. Here if n's value is equal to 0, n's factorial is 1. If n's value is greater than 0, n's factorial is represented as n into n minus 1's factorial. So here the difference is in iterative process we are representing n's factorial as n into n minus 1 into n minus 2 till 1, and here we are representing n factorial in terms of n into n minus 1's factorial. So here we are defining the solution in terms of the subproblems factorial here, that is n minus 1. 4's factorial. 4's factorial is represented as 4 into 3 factorial. 3 factorial is represented in terms of 3 into 2's factorial. 2's factorial is represented into 2 into 1's factorial, and 1's factorial is represented as a 1 into 0's factorial. So 0's factorial is a known thing, that is 1. So 1 into 1 is 1. Here n's factorial is defined in terms of n minus 1's factorial, which is in turn is defined in terms of n minus 2 factorial. n minus 1's factorial is again represented as a n minus 2's factorial. So the above process defines as object in terms of a simpler case of itself. This process is called as a recursive process. So we are representing the solution again in terms of a solution of sub problem. So this process is called a recursive process. Now here, what is recursion? It is an alternative way to iteration or loop structure. So loop structure we have studied already in the C programming language, that is for loop, while loop, do while loop. Now recursion is often more elegant and concise than a loop, but as it is very elegant, but sometimes it is very inefficient for some cases. It is not always applicable for or efficient for all problem solution. For some problem solution only the recursion will be efficient. Recursion should be considered when a problem can be defined in terms of successive smaller problems of the same type, that is recursively. So it is applicable only when if you are going for attempting the solution for that problem, the problem itself again the sub-problem's solution. Eventually the problem gets small enough that the answer is known. So as we are dividing the problem in sub-problems till that smaller becomes small, that we will know that for that problem what is the solution. So that kind of problem solution is called as a base case, and reducing the problem size leads to the base case. Sometimes the work of the algorithm is done after the base case is reached. So for some cases it is possible that in between only you are getting the result, and for measure of the cases you will get that once you reach the base case only, then only you will get the final result. Now this is the outline of a recursive function. We started with the iterative process, then recursive process, recursion. Then what is recursion process? When we are giving the recursion solution, how we are going to define the recursive function? In that case, as I said, base case. So if you know the solution for the subproblem, then provide the answer. That is a base case. Else, if you don't know the answer, then make a recursive call to the smaller version of the same problem. So it is a subproblem. So if the answer is not known, then it will go for the recursive case, means the call to the smaller version of the same problem is done. So in this there will be two cases, basically base case and recursive case. Base case is the one where we know the answer, and like for example in a factorial case, zeros factorial is 1, we know that, so that is a base case. And recursive case where we don't know the answer, then we are dividing the problem again in the subproblem and we are calling recursive call, we are doing that. So here is the example of factorial with the iterative method. You already seen what is the n factorial, how it is represented, n into n minus 1 till becomes n for n is greater than 0. Now this is the iterate function is giving the iterative solution for factorial n. N is the value passed if factor is initialized to 1. In this loop structure is used for iteratively multiplication to get the factorial of n. I's value is ranged from 1 to n, and i's value is multiplied repeatedly till we get the factorial of n value, and it is returning the fact. Second is the factorial using recursion method. In this here we have defined here factorial function, that is a recursive function, because here base case is defined here. Base case is for factorial, if n's value is 0, we are returning 1. So if it is not 0, then the recursive call is done for the n minus 1, that is x value is n minus 1. So this is the recursive call, which is a this is representing recursive case, and this is a base case. So in the recursive case, a recursive call for the factorial function is done by passing the n minus 1 value here. Then once n's value becomes 0, returning the 1, and the main function call for the factorial 4 is done here. The value is written and displayed. We will see how the actual factorial function, recursive call function is done. In this table, the factorial 4 call is done from the main method, which is from the main method. With the in the factorial call, n's value is 4, which is not equal to 0, so it will go for n minus 1 call factorial 3. In this case also n's value is not equal to 0, it will go for factorial 2 call. Then in this also n's value is not equal to 0, factorial 1 call, then factorial 0 call. Here the base case is achieved, n's value is 0, so it is returning the value 1. So this value is written to factorial 1. So here the value 1 will be written where n's value is 1. 1 into 1, 1 is written to factorial function call of factorial 2. Then 1 into 2 is written to factorial 3, and factorial 3 is returning the value 6 to factorial 4, and factorial 4 is returning the value 24 to main function. So in this way the recursive function call is done. For the same example, we will see how the recursive call tree will be drawn. Just now what we have seen is in the tabular format, same recursive call we are showing in the tree format. So for the same example, factorial 4 call is done till n's value becomes 0. Then 1, factorial 0 returning 1, factorial 1 is returning 1, factorial 2 is returning 1, factorial 3 is returning 4, and factorial 4 is returning 24 to main method. So this is recursive call tree. Recursive procedure, a procedure that contains a procedure call to itself. So function is calling itself is called as a recursion. Procedure called to a second procedure which eventually causes the first procedure to be called is known as a recursive call. So the another definition of recursive procedure is what? The procedure is calling second procedure, and that procedure again eventually causing the first caller procedure. This particular call method is also called as a recursive procedure. We already seen what are the two cases are there satisfied by the recursive procedure, the base case and general recursive case, which here it is called as a general method. Base case is the smallest case that is proposed without recursion acts as a decision criteria for stopping the process or computation, and general method that makes a particular case to reach nearer result, that is to base case. So general method is a recursive call where you are not getting the sub problems for the that we are not knowing the answer solution, that is a recursive case or general method. Next example of the recursive call, to see the recursive function, is the Fibonacci sequence. The Fibonacci sequence is the sequence of integer in which the number in this sequence is defined by the summation of two preceding elements. Here 0 and it will start with 0 and 1. The next number is defined by the addition of these two numbers, that is 1. Next number in this series is addition of previous two numbers, that is 1 plus 1 2. Next number 3 is addition of 1 plus 2. 5 is the addition of 2 plus 3. Like this Fibonacci series will be defined. In general, formula for Fibonacci of n is, if n's value is 0 or 1, it will be equal to n. If n's value is greater than or equal to 2, it will be defined in terms of Fibonacci of n minus 2 plus Fibonacci of n minus 1. So here we are calling that same function here to get the solution. The Fibonacci sequence function is defined here. Fibonacci of n, if as base condition is defined here, n is value 0 or 1. So if n is less than or equal to 1, return the n. So that is the n here. And if it is not less than or equal to 1, means if it is greater than equal to 2, we are calling the same function for n minus 1 and for n minus 2, and the return value we are adding and returning. So this is recursively called two times the same function and to get the result. So this is it will give the Fibonacci sequence. So we'll see how the recursive call tree will be there for the Fibonacci of 4. Here first Fibonacci of n, that is the value of n is 4, then 4 is not equal greater than equal to 1. Fibonacci of n is call is done, which is 3. Then Fibonacci of 2 is also not greater than equal to 1. Now Fibonacci of 1, where value base case is reached, so here it is returning 1. Now here n's value is 2, we have done n minus 1 call. Another call is n minus 2, it is returning 0. The addition of the values written by Fibonacci of n minus 1 and n minus 2 is 1 plus 0, which is written by Fibonacci of 2. Now in this n minus 1 call is done, so next is n minus 2 call. So n value is 1, it is returning 1. So addition of 1 and 1 will be returned by Fibonacci of 3, that is 2. Next Fibonacci of n minus 2 call from Fibonacci of 4 is done. Here again Fibonacci of n minus 1, it is returning 1. Fibonacci of 0, it is returning 0. Addition of these two will be returned to Fibonacci of 4. So addition of these values returned by n minus 1 n minus 2 function call is 2 plus 1 3, which is returned to main function. So Fibonacci of 4 is, fourth position is value is 3. Fibonacci series using for loop is defined here. This is just to understand how the Fibonacci series will be displayed using the loop construct or using the iterative method. Here you can see the condition is checked here. If n is equal to 0, only a is displayed, else a comma b, these two values are displayed. Then it starts with I is equal to 2 till I becomes n. By repeatedly adding the a and b, a b is initialized to 0 1, then displayed, then again the new values are assigned here, and repeatedly this task is performed. Thank you for listening this presentation.